As we deepen our understanding of how cellular maintenance systems drive aging and metabolic health, it's becoming increasingly clear that single-agent therapies, while promising, may not fully address the complexity of age-related decline. Nicotinamide mononucleotide (NMN), a precursor to NAD, has garnered significant attention for its ability to rejuvenate energy metabolism, restore autophagy, and reduce chronic inflammation, particularly in aging and obesity contexts. Yet the emerging strategy of combining NMN with other autophagy-enhancing compounds, such as spermidine, may offer a synergistic approach that magnifies therapeutic outcomes beyond what either agent can achieve alone. Autophagy is a multi-step process involving initiation, cargo recognition, autophagosome formation, lysosomal fusion, and degradation. This process is tightly regulated by nutrient-sensing pathways like mTOR, AMPK, and SIRT1, all of which are sensitive to cellular energy status and NAD availability. NMN supplementation primarily boosts NAD pools, thereby activating sirtuins and enhancing mitochondrial function and autophagic efficiency, especially in metabolically active tissues like liver, skeletal muscle, and adipose. Spermidine, a naturally occurring polyamine found in certain foods, stimulates autophagy through a different but complementary mechanism. It inhibits EP300, an acetyltransferase that suppresses autophagic gene expression, thereby unlocking transcriptional programs that drive cellular renewal. When combined, NMN and spermidine may offer a dual activation of autophagy. NMN enhances the energy state of the cell and facilitates deacetylase activity via sirtuins, while spermidine relieves epigenetic suppression of autophagy-related genes. This coordinated action not only improves the flux and efficiency of autophagy, but also expands its benefits across multiple tissues. In aged obese models, this synergy translates to improved metabolic flexibility, reduced adipose inflammation, and greater preservation of organ function. In rodent models of aging and diet-induced obesity, early studies have shown that NMN and spermidine co-administration produces additive or even synergistic effects on fat loss, glucose regulation, and mitochondrial biogenesis. While NMN alone can restore insulin sensitivity and reduce hepatic steatosis, the addition of spermidine appears to accelerate these changes, particularly through enhanced lipophagy, the targeted degradation of lipid droplets. This contributes to reduced visceral fat mass, improved adipokine profiles, and better systemic energy partitioning. Importantly, both agents influence adipose tissue remodeling, but through slightly different routes. NMN boosts NAD and supports mitochondrial fusion and thermogenic activation, which is especially relevant in beige and brown adipose depots. Spermidine, meanwhile, enhances autophagy-dependent lipid droplet turnover and reduces pro-inflammatory cytokine expression. Together, they create an internal environment more conducive to browning of white fat, increased oxidative metabolism, and resistance to fat accumulation despite aging. Their combination also seems to confer protective effects on the liver, a major metabolic hub compromised by senescence and fat infiltration during aging. NMN enhances mitochondrial health and fatty acid oxidation in hepatocytes, while spermidine reduces stress and activates hepatic autophagy pathways more robustly. The result is improved hepatic insulin sensitivity, reduced triglyceride storage, and normalized lipid transport, all of which contribute to a more youthful metabolic profile. Beyond fat and liver metabolism, the co-treatment supports muscle maintenance and stem cell function, critical for preserving mobility and systemic metabolic rate in aging. NMN stimulates mitophagy in skeletal muscle and supports mitochondrial density, while spermidine has been shown to improve autophagic flux in muscle stem cells, aiding in regeneration and reducing fibrosis. These effects are essential for preventing sarcopenic obesity, a condition where declining muscle mass combines with increased fat mass, leading to frailty and metabolic disease. There's also growing interest in the impact of NMN and spermidine on the immune system, particularly in their capacity to rejuvenate immune surveillance and reduce chronic low-grade inflammation. Both compounds modulate the gut microbiome in ways that appear beneficial, increasing bacterial species associated with improved gut barrier function and reduced endotoxemia. Because gut-derived inflammation is a known driver of obesity and insulin resistance, this secondary effect could be a major contributor to the metabolic improvements observed. From a longevity perspective, The combined enhancement of autophagy by NMN and spermidine may help mitigate not just metabolic dysfunction, but the broader cellular senescence that underlies age-related diseases. Enhanced autophagic clearance of damaged mitochondria, protein aggregates, and senescent cells leads to improved tissue function and potentially extended health span. Indeed, both compounds have individually been shown to increase lifespan in various model organisms. Whether this extends to humans remains to be seen, but the mechanistic overlap suggests a promising direction for combinatorial anti-aging therapy. Another critical benefit of using NMN and spermidine together is dose modulation. Higher doses of NMN may be required in isolation to achieve certain metabolic benefits, especially in older individuals. However, when used alongside spermidine, those same benefits may be attainable at lower NMN doses, reducing potential risks or cost burdens. This opens the door to safer, more efficient supplementation strategies that are better tolerated across age groups and comorbidity profiles. In conclusion, the therapeutic pairing of NMN and autophagy activators like spermidine represents a powerful advancement in metabolic and anti-aging science. By targeting distinct but interconnected pathways of cellular renewal, this strategy not only amplifies autophagic function but also translates that enhancement into real-world metabolic resilience, better glucose control, reduced fat mass, improved mitochondrial health, and even potential lifespan extension. As research moves toward clinical translation, this combinatorial approach may become a cornerstone in the personalized management of aging and obesity, not as a temporary fix, but as a systematic restoration of the body's self-maintenance machinery.